Brace yourself. You're about to hear one of the most unusual sounds ever. It's come from space, and it's the sound of two black holes colliding. But first things first. Our ears are designed in a special way, which helps us translate sound waves. But these sound waves become mute once the medium they're traveling through comes to an end. It happens when, for example, the atmosphere of Earth gives way to the vastness and emptiness of the cosmos. At the same time, there are some sound waves that can move even through a vacuum. And we can translate these vacuum-friendly waves into sounds our human ears can hear. That's kind of like radio transmissions work. Over the past few decades, people have sent quite many satellites to the far reaches of the solar system, and even beyond. These spacecraft are equipped with sensors designed to hear such things as radio and plasma waves, flowing freely through interplanetary space. These instruments are crucial for research and communication reasons. An additional bonus is that now we can finally hear different kinds of space waves as audible sounds. The results are often ear-splitting sounds, and sometimes audios are downright scary. Usually, when two black holes collide, they don't produce a sound. And still, thanks to modern technologies, we can now listen to this terrifying cosmic event. Do you hear it? This chirping sound is the sound that two black holes produced while slamming into each other around 1 billion light-years away from our planet. Interestingly, the tone of the sound rises when the holes spiral closer to each other and stops abruptly when they eventually merge. Now, do you hear that long, low buildup? It means that the merger is quite slow, more sedate, and the black holes taking part in this event are relatively lightweight. A more abrupt chirp is a sign of a fast merger, where the black holes are rather large. For example, the pair that produced this sound combined and created one black hole more than 80 times the mass of the Sun. Since each of these black holes weighed as much as several stars, they were hefty enough to produce waves while passing through space. I mean gravitational waves. They are undulations in the fabric of space-time, fanning outward at the speed of light. You can probably compare them to the ripples that appear on the surface of a pond after you throw a rock in the water. Naturally, the sound of black holes colliding isn't the only unusual noise recorded by our equipment. NASA's Juno probe passes by Jupiter every few weeks at a speed of up to 130 miles per hour and plows through all kinds of invisible fields in the process. And one of the most powerful signals it has recorded is Jupiter's bow shock. That's the point where the planet's magnetic field pushes against the incoming wind of solar particles. The sound produced during this standoff sounds similar to a sonic boom. Or this sound. It was produced by the Stardust space probe when it was passing through the dust left by Comet Tempel 1. In the process, debris hit the body of the spacecraft. It sounded as if some creature was rapping at the window or hurrying across a hard floor. Let's have a look at NASA's nuclear-powered Cassini spaceship. It spent 13 years exploring gas giant Saturn and its numerous potentially habitable moons. This mysterious and a bit spooky sound is actually radio waves emitted by the massive planet. Such waves are caused by a phenomenon which is similar to the one producing auroras on Earth. Speaking of our own planet, it's surrounded by plasma. It consists of hot, ionized particles generated by sunlight. They're constantly slamming into Earth's atmosphere. NASA's Polar mission, which was launched a few decades ago, managed to record this breath-like hiss. That's what plasma orbiting our planet sounds like. As for these weird sounds, NASA doesn't say which space probe recorded them, but they're coming from Jupiter's largest moon, Ganymede. It could have been the Galileo spacecraft, which orbited the system for around 8 years. But it probably doesn't matter so much. Just listen to this creepy noise that sounds like screams trying to break through from some hidden place.
Stellar collisions occur about every 10,000 years and are an incredible spectacle, but they're only fascinating to watch when they happen tens and hundreds of light years away. If a star collides with our own sun, it will be a global cataclysm that will leave no chance of survival to anything. If it happens, it will most likely involve a rogue star. These are stars that aren't bound by gravity to any galaxy and move independently through space. And such a star has already paid a visit to our solar system. To be more precise, 2 stars. This is Scholz's star. It's a binary system consisting of a red dwarf, which weighs about 86 times as much as Jupiter, and a slightly smaller brown dwarf, which is 65 times heavier than Jupiter. About 70,000 years ago, these stars approached the boundary of our system, the Oort cloud. It's a kind of shield of comets and cosmic bodies that surrounds our solar system. Humanity was already around at the time and probably began spreading worldwide from Africa, and they could have witnessed a dim red light in the night sky. And even though Scholz's star flew by us at a distance of about 0.8 light years, its gravitational field strongly influenced the movement of different cosmic bodies. But what if such a star didn't pass by, but went straight to the center of our solar system, to the Sun? Scientists say this may happen in 1.3 million years. Meet GLIESE 710. This star has 60% of the Sun's weight and moves steadily towards us. Like people 70,000 years ago, we will be able to see the light from this orange dwarf with the naked eye. First, GLIESE 710 will approach our shield, the Oort cloud. The star's gravitational field will capture some meteorites and throw them in all directions. The number of meteorites falling down on Earth will probably increase tenfold then. After that, GLIESE 710 will move on to the planets. It will consume them one by one, scattering their fragments all over the system. And while small meteorites wouldn't disturb us much, now we'll have a real threat on our hands. Planet shards the size of a meteorite that wiped dinosaurs off the face of the Earth will zoom straight at us. The star is getting closer and closer to the Sun, and if we somehow survive the falling fragments of our former neighbors, now GLIESE 710 will have zoned in on us. Gravity and temperature will just tear the Earth apart. Still, this terrible sight will long since have had no onlookers. Humanity will have evacuated from the Earth long before, of course. Earth, Venus, Mercury. GLIESE 710 has approached the Sun. The smaller star will orbit the big one, gradually closing in on it in a spiral. With time, the 2 stars will merge, and if their total weight exceeds a certain value, a disaster will occur. The temperature of the rogue star grows and nuclear reactions inside it accelerate. Little by little, the inner part of the star heats up to a critical temperature, and a supernova explodes. In a few seconds, all the substance of the star is scattered into space, and a powerful explosion will wipe out what's left of our solar system. But so far, GLIESE 710 is 64 light years away from us, and there's still a chance it will change its route and pass by peacefully. And what if 2 more unusual stars collide with each other? This is a neutron star. It's very small, only about 12 miles wide, but its weight is comparable to that of the Sun. This ball is extremely heavy. A neutron star collision can generate one of the most mysterious phenomena in the universe. 2 neutron stars fall into each other's gravitational field. As they move, they gradually approach each other in a spiral. And just as they almost meet, 2 different scenarios can unfold. If the weight of the 2 stars is relatively small, then after the collision, their combined weight gives life to a new neutron star. But if our participants are a little heavier, then when they collide, their weight exceeds the critical point, and this creates a magnetic field trillion times stronger than the Earth's. All this happens in just 1 or 2 milliseconds and is accompanied by a blindingly bright flash. This is a short gamma ray burst. It's considered the brightest and most energetic electromagnetic event in the universe. A black disk appears at the collision site of the neutron stars. It's a black hole. Scientists believe this is one of the possible ways of its appearance. black holes have so much weight that they warp the space and time around them. They have an incredible gravitational force. If something gets too close to a black hole, it's unlikely to ever leave it. Even the photons of light, the fastest particles in the universe, are unable to shake off the black hole's grip. By the way, an ultramassive black hole is at the center of our Milky Way galaxy. It can weigh millions and billions of times more than the Sun. Now we know how a black hole is born, but what happens if two black holes collide? Astronomers have already seen such an event. For about 7 billion years, two huge black holes were circling around each other, gradually getting closer. One had the weight of 66 suns, and the other had 85. At the moment of collision, the big black hole absorbed the smaller one and grew even larger. The new black monster weighed as much as 142 suns. During the collision, a huge amount of energy was released, equivalent to the mass of 9 suns. The energy gave the universe a hefty shake, and the vibration from the impact has only recently reached Earth's telescopes. But in 4.5 billion years, an even more significant collision will occur. Our entire Milky Way galaxy will collide with the Andromeda galaxy. Although Andromeda is 2.5 million light-years away from Earth, it's still our closest neighbor. Our universe is expanding, and there's movement inside it. Scientists have found that Andromeda is moving in our direction at a speed of 74 miles per second. So, in about 3 billion years, stars and hot gas of this galaxy will be visible to us with unaided eyes. Then it will crash into our own galaxy within 1 or 2 more billion years. The duo will move around each other like a yo-yo. They will approach one another and then pass by at a very close distance at an incredible speed. They will begin to move away from each other, but the force of gravity will bring them back. And then another collision will begin. But this time, they will form one giant galaxy called Milkomeda or Milkdromeda. It's hard to predict what will happen to us and our planet. In one scenario, we may not even notice the consequences of the collision. Despite the galaxies being full of stars and other celestial bodies, they still consist mostly of emptiness. Stars are really far away from each other. For example, if we imagine that our sun is the size of a coin, then the nearest star, Proxima Centauri, would be as far as the distance from Philadelphia to Detroit. That's about 450 miles. So there's lots of space between the stars and the galaxies. The second possible scenario is when our solar system is left alone in dark space. When galaxies collide and circle around each other, a lot of stars will be ejected as if from a catapult. Look at the merry-go-round in an amusement park. When it spins, the centrifugal force pushes the swings out. And if you unhook the swings while it's spinning, it will fly away really far. The same phenomenon occurs with many stars during galactic collisions, and our sun might be among them. In this case, we will hardly notice the difference. Life on Earth will continue at its usual pace. The only disadvantage is that our usual night sky will begin to disappear, and in time, it will turn into a black void. The last and most unlikely option is that our solar system will collide with another star. Well, in this case, all life on Earth will be doomed, just as if a star like GLIESE 710 would crash into the sun.
So, you're going on a journey to a black hole. Well, you'll need a lot of provisions, because the nearest black hole is 1,011 light-years away. This black pearl was found in the solar system called HR 6819. It was hidden in orbit with 2 other stars, which you can see with the human eye. Scientists have been studying this system since the 80s, but this winter it revealed its main secret. This particular black hole is considered relatively small, but despite this, its mass is 4 times bigger than our Sun, and it's 2,500 light-years closer to Earth than the next nearest black hole. But don't worry. For people, the distance of 1,000 light-years is unreachable. For example, if we were to make a model where the Earth's distance to the Sun was only 0.05 inches, you would have to travel about 4 miles to get to this black hole. But our galaxy, the Milky Way, is about 100,000 light-years wide. So the distance of 1,011 light-years doesn't seem that long in comparison. But before you jump inside this black giant, let me try to discourage you. A black hole is a place in space-time where nothing can leave its orbit. No particles, electromagnetic radiation, or even photons of light can escape from a black hole. So you should understand that a journey to such a dangerous object as a black hole is a one-way ticket. And the way black holes are born is incredible. When a star runs out of fuel, the star collapses under its own weight and becomes a black hole, like the supermassive black hole in the Messier 87 galaxy. Its mass is 7 billion times bigger than the Sun, and it was discovered by the Event Horizon Telescope in April 2019. Okay, good. I see you've already bought a ticket for a faster-than-light spaceship. Since there's no refunds, and you don't want to lose the money, it's time to get ready for the trip. Oh, feel free to leave your luggage at home. 3, 2, 1, off you go. You're leaving Earth's orbit, saying goodbye to the moon, and don't forget to cheer up Pluto by saying it is big enough to be a planet. Then you pass the highway of dark space, and here's your stop, the black hole. Put on your suit because you're going into outer space. The first thing you see is the event horizon. The gravitational field of a black hole bends the light around its edges, so the event horizon is like a croissant for the observer. Once you reach the event horizon, though, you won't be able to get back out. You may also notice that there's some kind of chaos in this ring. Some lights move in different directions. This happens because you get a mirror effect. But we still don't know what's inside the black hole. So you decide to send in a drone first. The gravity field of the black hole quickly draws in your metal buddy. As soon as he enters the event horizon, his body begins to change its shape. It becomes elongated like a strand of spaghetti. And the closer it gets to the center of the black hole, the longer it becomes. You also notice the drone has slowed its movement and now gradually approaches the black hole center. This is another effect of this space monster. The black hole's vast mass curves not only space but also time. If you hang one watch next to a black hole and another on the wall in your bedroom, you will see that in the first watch, the second hand has barely moved, while a whole day has passed on Earth. And the more massive the black hole, the stronger the effect of slowing time. Theoretically, if you have a spaceship that can overcome the gravity of a black hole, you can fly to it and wait for a few seconds. During this time, your friends on Earth would live a whole life. The flashlight on the head of your drone has turned red. This color change has happened for the same reason. The clocks that are deeper in a gravitational well tick slower when observed from outside. This also affects the photon's wavelength. We see red light because it has the longest wavelength of any color in the visible spectrum. All these things actually happen to the drone in a split second, but it seems slow to you because of the time warp. Alright, it's time to enter the black hole yourself. The final preparation is your suit that will protect you from Hawking radiation. This radiation is created by black holes due to quantum effects near the event horizon. Hawking radiation reduces the weight of the black hole. So if the black hole doesn't absorb more mass from nearby objects, it becomes smaller and then simply disappears. Oh yes, the black holes are also mortal. But Hawking radiation can turn you into ash, and you'd lose the chance to see the black hole from the inside. Okay, now let's do what you traveled 1,011 light-years to do. One big jump, and you're caught in the gravity field of the black hole. This is the point of no return. But your distance allows you to set a stable orbit so that you can spin around the black hole like the moon around the Earth. A little higher, and you'll be thrown into infinity. A little lower, and you will be dragged into the black hole. So, theoretically, planets could exist at this distance, and even inhabited if there were the necessary conditions. A couple of minutes later, and you are approaching the event horizon. Oh, look down. Your body is so long. You are now spaghetti yourself. Look around you. The stars are turning blue. This is called gravitational blue shift. As you fall into a black hole, its gravitational field pulls the photons of light down, giving them energy. Their wavelengths are getting shorter, so the red photons change into blue and everything starts to look blue. Now you are right outside the event horizon, and the only thing you can see is a round blue beam of light above you. But soon you will stop seeing even that. So, you've survived the strong gravitational field of a black hole, and the Hawking radiation didn't burn you to ash. You are now in the heart of the most mysterious object in the universe. You have front row seats, but the view is not that impressive. This is the darkest place you've ever been to. Even the usual laws of physics just stop working here. Theoretically, time goes by so slowly here that your home planet could no longer exist. And a new black hole could appear in place of our sun, but you will live exactly as long as there's enough oxygen in your suit. But what if this cosmic object is actually a wormhole that leads to another place in the universe? This is a popular theory, but scientists still can't confirm it. But if it is true, then after a while, you'll see a blue light again. Now you'll experience the same fall, only in reverse. Once you leave the singularity, which means the black hole's heart, you will be in the event horizon. The light from the stars gradually changes from blue to red. You can feel the shaking and warmth from the Hawking radiation. But then you're thrown into outer space, perhaps in some faraway galaxy. No one knows what will happen next. Are you in contact with an unknown life form? Or will the conditions there be intolerable for a human being? Or maybe you will not go to another place in space, but to a parallel universe. This theory also exists. According to it, black holes are portals to other dimensions. Simply put, there are endless copies of our universe. Every time you were faced with a choice, your twin from another universe chose something else. But let's leave that to fantastic movies. Right now, the journey into a black hole is merely impossible for humanity. We can't even reach the nearest one. But one day, we will learn more about these space objects' nature, and maybe this knowledge will push humanity forward and make us a multi-galactic civilization.